Absolutely everything comes to an end. Stories, books, movies, people. Even stars eventually die one day. And among all the things that inevitably come to an end, there is one that we are all a part of, the universe, which also has an expiration date. And although it's impossible to know exactly when the universe will end, the latest discoveries made by modern science have allowed us to outline 3 major possible scenarios for its end. There is one that, in my opinion, is the most frightening of all, as its consequences are literally tearing everything apart. This scenario, known as the Big Rip, was brought to light 2 decades ago. This was done by 3 researchers who published a paper simply titled Phantom Energy and the Cosmic Apocalypse, and in which they described the behavior of a universe where the rate of expansion of space is exponential. And what they show there is that it's possible that in the distant future, the universe, a victim of its own rampant expansion, could, in a way, commit suicide by gradually tearing galaxies, stars, atoms to shreds, down to the smallest piece of matter it contains, before finally managing to rip apart space-time itself. And just for the pleasure of watching the universe die, we are going to explore this scenario in gory detail, a scenario whose arrival may not be as far from us in time as we think. The story begins in the distant future. It's hard to say exactly when, for reasons I'll mention at the end of the video. But one thing is certain. When the first ominous signs that the Big Rip has begun appear, the universe has less than 1 billion years left to exist. The Big Rip isn't an instant apocalypse, but its arrival always begins in the same way. When observing the cosmos on large scales, we notice that the expansion of space has suddenly started to grow exponentially. And in this universe that's accelerating away, the deep sky, already darkened by the expansion, empties of light unusually quickly, as if the cosmos were being swept away by a raging ocean of space. Seen through our telescopes, the nearby superclusters of galaxies are beginning to break apart, because the gravity that holds them together collectively is overwhelmed by the acceleration of the expansion of space. The paths of the galaxies located on the outskirts of these clusters begin to stretch, and these are the first to be pulled away, drifting alone into the vast cosmic voids. This process of the disintegration of large galactic structures takes place over hundreds of millions of years, but eventually, all the galaxies in the universe, including ours, end up drifting alone in the vastness, with no gravitational bond left to anchor them. Meanwhile, the exponential expansion of space has almost completely emptied the deep sky of all light, turning our Milky Way into a solitary island of light, lost in an ocean of almost pure darkness. Through telescopes, all the other galaxies in the universe have visually disappeared. Only the stars within our galaxy, the Milky Way, remain visible. So far, the effects caused by a now frantic expansion of space are rather subtle. They only appear on the very large scales of the universe and are so distant that they don't impact your daily life. But soon, this scenario will take a more personal turn. Because about 60 million years before the Big Rip, the matter that makes up all the galaxies in the universe starts coming apart too. We have now passed the point where the acceleration of the expansion of space surpasses gravity's ability to keep galaxies as coherent groups, rich with hundreds of billions of stars held together by their mass and proximity. And now, the speed of the expansion of space is able to break their gravitational bond. In the sky, we begin to notice that the stars located at the edges of our galaxy have increasingly extended orbits, and some even start to drift away, a sign foreshadowing the inevitable unraveling of everything around you. For millions of years, all the galaxies in the universe, gradually dismantled by expansion, see their stars, as well as their nebulae and clouds of gas, torn away from them, before drifting off into the cosmos, with no center of gravity to hold on to. If you were to gaze at the skies of that era, you would see the milky trail that lets us see our galaxy from the side gradually fade away and then disappear. while the stars in the sky vanish from your field of vision until the sky becomes completely black. In the universe, all the galaxies have then been torn to shreds, and the stars, along with their retinues of planets orbiting them, now drift alone in the cosmos, in an ever vaster space where the acceleration of expansion reaches terrifying proportions, to the point that 3 months before the coming of the Big Rip, planetary systems begin to break apart. Within them, the orbits of the planets bound to their stars spread out. The most fragile ones are the first to break away, and within just a few weeks at most, all the planetary systems in the universe see their gravitational cohesion collapse. The asteroid and comet belts have been shattered, and all the planets have been torn away from their stars. The gas giants like Jupiter have also drifted away into the darkness of space. However, they still manage to hold on to their moons, which are close enough for the gravitational bond between them to withstand the relentless expansion of space. But soon, overwhelmed by this expansion whose acceleration keeps increasing, all the moons will in turn be torn away from their planets one by one. At this stage, the universe contains only solitary objects moving through a space-time that is expanding so rapidly that the light emitted by the stars now struggles to travel through it. That the stars, like the drifting planets, are still coherent and intact objects, whose integrity is preserved by the force of gravity, which, at their scale, still manages to overcome the effect of the phenomenal expansion of space. They are on the brink. 30 minutes before the Big Rip, the disintegration of all bodies with Earth's mass begins. Peeled from top to bottom, like regular modeling clay balls pulled apart, they see their atmosphere and their oceans, if they have any, rapidly escape into space, closely followed by the rocks that make them up. And they are torn away at incredible speeds. Then, in the process, space, which keeps accelerating, starts to unravel and tear apart the most massive planets before turning to the stars. These, incomparably heavier than the planets, survive a few more minutes before they too are torn to shreds. On a macroscopic scale, gravity, unable to hold bodies together, has finally given up, faced with the methodical and ever-accelerating stretching of the fabric. Space-time, whose exponential acceleration now reaches proportions that defy understanding. So even if you could take refuge in space inside an armored, compact sphere, nothing could protect you from what is happening. Because the expansion will reach such values that it will disrupt matter itself at microscopic scales. 10 to the power of -17 seconds before the Big Rip, the tiny space between the electrons and the nucleus expands faster than the speed at which the force binding them travels. So much so that electromagnetism, which is responsible for the binding energy that allows atoms to bond and form molecules, gives way and the atoms break apart. All the atomic structures in the universe instantly disintegrate, dissolved by the expansion. The good news is that this final tearing apart, with no escape and happening absolutely everywhere at the same time, takes place in such a brief amount of time, that even if, by some miracle, you had managed to survive until then, the tearing of matter caused by the acceleration of the universe would necessarily be painless. All interaction becomes impossible. A void opens inside each particle, and energy disappears. Then, in the very last tiny fraction of a second of the universe's existence, the runaway expansion of space-time ends up tearing it apart. After that, there is no place or time left. The universe has died from its own excess. Without ever needing to increase the temperature. By tearing apart the very foundation that allowed it to exist, it simply ended all possibility. To understand why this scenario of uncontrolled expansion, leading to an end where everything is literally torn apart, is now considered plausible, we need to look into the nature of the mysterious force that drives the acceleration of the universe's expansion, which is called dark energy. Let's start with a bit of history. At the turn of the 1990s, by studying the light coming from the explosion of giant stars that serve as standard candles and allow us to measure distances, On the large scales of the universe, it was discovered that the expansion of space is accelerating. The universe we live in today is not just expanding, it's doing so more and more rapidly. It is believed that this acceleration of expansion is due to the presence of dark energy, which seems to fill all of space, giving it a kind of repulsive effect. Except that the true nature of this dark energy, which still represents nearly 70% of the total energy of the cosmos today, remains mysterious. Is it an intrinsic property of the vacuum? Something radically different? We don't really know for now. The fact remains, there is a kind of energy that continually expands space. And this energy acts in such a way that today it has no impact at scales smaller than the absolutely gigantic distances that separate galaxies. All the measurements made so far suggest that dark energy is what we call a cosmological constant. If you measure the amount of dark energy present in a volume of space, of any size, in any direction in the universe, and you repeat your measurement a few million years later, you will get the same value. Because the amount of dark energy in each volume of space in the universe is always the same, even as space expands. I know, it's extremely weird. The fact that dark energy seems to be constant over time, hence the name cosmological constant, prevents it from tearing apart coherent structures like galaxies, planetary systems, or any aggregate of matter. And here we are, tempted to let out a big sigh of relief. The universe seems safe from the Big Rip. Except that in reality, it's possible that dark energy isn't a cosmological constant. Hang on a bit and be prepared to lose a few hairs. You'll see, it's fascinating. The ultimate fate of the universe depends largely on the value of a single letter. To describe the behavior of dark energy, physicists use an equation of state parameter that they called W, which links the pressure of dark energy to its density. And what's confusing here is that the value W takes allows us to know how the universe will evolve in the future and in what way it might die. If W is greater than 1, it means that the density of matter present in the universe is enough for gravitational attraction to overcome the expansion of space caused by dark energy. And in the future, the cosmos should slow down, then stop and reverse its movement, eventually collapsing in on itself. Heading toward a dramatic end where all the matter, light and energy contained in the universe come back together, concentrated in an extremely small volume, in the form of a grand finale, like an apocalypse of heat and fire. Cheery. If W equals 1, then dark energy is a cosmological constant. The expansion of space will never stop, but its effects will only be felt on the very large scales of the cosmos. And the universe will continue to expand eternally and head toward a slow agony stretching over periods of time so vast that they approach the very definition of eternity. This is the scenario of the universe's thermal death, the Big Freeze, which we discussed earlier in this video. And this fate of a continuous slide whose silence is cold is the one that is mostly accepted today, because our most precise measurements seem to give W a value very close to 1. Except that the statistical margins of error do not allow us to rule out that W is actually very slightly less than 1. If W is less than 1 even by just a tiny billionth of a point, then dark energy is not a cosmological constant, but a terrifying phantom energy, which has an energy density that increases very slightly over time and as the universe expands. Discovering that dark energy turns out to be phantom energy would be like identifying the presence of some kind of incurable disease nestled in the fabric of reality. A disease that will inevitably trigger, over very long timescales, an exponential runaway of the universe's expansion, to the point of dismantling, in a very precise order, all the components of reality in a relentless and unprecedentedly violent process until even the structure of space-time itself is torn apart. The good news is that even if the Big Rip can't be completely ruled out, the margins of error in the measurement of W tell us that, at worst, the Great Tearing shouldn't be able to happen for another 150 billion years or so. That should give you plenty of time to pay off your mortgage. In any case, I have to say that I personally like the idea of a death that tears everything apart, with no big crunch, no final big bang, no end credits or curtain falling, just a simple tattered fade to black.